record. Okay. Good morning. Oh, wow. I wasn't actually expecting a good morning. That's nice. Usually I just talk to myself.
Yeah, it seems like we have a decent amount of energy in the class today.
Totally.
Whoa. Is that a normal way to spell Emily?
No, it's the Swedish way.
Oh, okay.
Yeah.
Have you ever been to Sweden?
I was born in Sweden.
You were born in Sweden?
Yeah. But I've lived there since I was 12.
Yeah.
So,
yeah. It's kind of like how I was born in Calgary, but. No, but wait, do you know Swedish?
Oh yeah.
Huh. Could you do the lesson in Swedish?
Visst kan jag det. Let's see here. I'm going to add a page here.
I just like how the quizzes are due so like soon.
Yeah.
Ours?
You know the chemistry one.
Oh, I moved it. Yeah. Yeah, that's what I want to make a big deal about. A big splash. Are you guys ready for this big splash? No. 17. We already established that last week, but then I forgot to update it. So there we go. I promise. The 17th. We're going to do the last of the material that will be on the test today. And then, I mean, if we kind of need to tidy it up on Thursday, then we've got time. I think the last of it, absolute values. So we'll kind of be a little bit off, but it's okay.
The 17th, the test is in person or?
Yeah. So the test is going to be here in class, closed book, obviously. Bring a calculator. Which is all, well, you'll need obviously a writing utensil of some sort, but in class, closed book, bring a calculator that you know and love, because I do bring a bag o' calculators, but yeah, man, what a nightmare. That's like my worst nightmare is getting just a random calculator for a test. Okay. So test number 1 will just be on chapters 1 and 2. Okay. I promise you this, I'm going to take questions from those assignments that you've been working on. Okay? So those online assignments, I don't know, you might call them quizzes, doesn't matter. I'll just steal questions from there. Obviously, the numbers are different, right? But you will have seen and worked on all these problems. Okay? So nothing crazy. I will use questions from the assignments. But I also posted, let's see here. I also posted kind of messy on my end. Let's go to a student view. Where is it? chapter 1 review problems and chapter 2 review problems. These are not for marks, obviously they're only for practice as it says, okay? And so these are the assignments that I need, the section, blah, 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 blah. That's where I'm gonna be stealing from. And then the review problems, I might steal from those as well, okay? From the assignments and the chapter review problems. Okay. Good. No surprises. Some of those are tricky, but because you've worked through them on your own time and I expect you to be able to solve them now, they're not going to be out of left field anymore. And so that's why I think they're still quite reasonable. Okay. Any questions before we start the last section in chapter 2? Okay. Section 2.5 is the absolute value function. Now, we know the absolute value function, it's one of our toolkit functions. What does it look like? It's a B, right? Bink, bink, just like this. So this is the absolute value of X, and we use these vertical bars just as a reminder to denote the absolute value. If we think about it this way, could we break this up into just 2 straight lines? We can, right? And so really what it is, what the absolute value function is it's a piecewise function, right? For one section of the graph, it's going to be, I'll start with the pink section that I did. This section is going to be f of x is x, right? Just a diagonal line, y equals x. Right? So just straight across the diagonal. And then on the orange side, this is also a diagonal, but now it's got a -1 slope, which means it's equal to -x. It's weird to say, but the air is too loud out there. That's yeah, right. It's so annoying. So the absolute value function is just the piecewise function, right? And so technically, right, in kind of applied sense, all it does is it drops the negative, right? Kind of turns negative values positive, right? But technically, it's because it's this piecewise function. So what it's saying is, okay, the absolute value of x is going to be a line at x, right? So y equals x, as long as x is greater than or equal to 0. Okay? And so what I'll do is I'll denote that with a solid dot at 0. And as long as it's greater than or equal to 0, you've got this line at x, y equals x. Then we move on and we say that, okay, if x is less than 0, so if x is negative, right, then the line is going to be -x. What happens if I have a negative number and I put it into -x, right? It kind of turns it positive, which is what the absolute value does, right? And so here, right, technically you're putting in a negative number and then it's negating it, turning it positive, right? So I'll put an open dot at 0 for the orange, because the 0 is handled by the positive x, even though it doesn't really matter. 0 is not really positive or negative. Okay, so absolute value function. piecewise function. That was a while ago that we introduced that in chapter 1, right? But now here it is again, right? This is probably the most kind of basic piecewise function that we can work with. What if we have to write an equation for this graph? So now, right, first thing I want to do is I want to recognize what's the general shape of this thing, right? It's the absolute value. Of course, we're in the absolute value section, but imagine we weren't, right? And you were writing the test. Now, I will say this, on the test, unless there's a spacing issue, I do try to keep it chronological so that as you work through the test, we're working through the sections that we worked through. So unless there's like a big question and then a little question I don't have room, then I do switch them. So don't, rely on it super heavily. But generally I just keep it in the same order. Yeah. So just in case that's helpful.
Is it like a fairly equal spread of each of the units?
Yeah. Once I have landed on something, I'll tell you what to expect from each kind of section. But yeah, relatively equal. Now, some of these, what we'll find is the later sections obviously build on the earlier sections. So sometimes I can ask kind of a later section type of question and still cover the earlier sections. But yeah, I'll give you an outline of what to expect. But I don't have it yet, because I haven't made it yet. All right. First thing we need to do, step 1, recognize that overall this is going to be an absolute value function. Recognize the absolute value function. So any manipulations are done to, so therefore, any manipulations are done to f of x is equal to the absolute value of x. Absolute value of x, we just saw, looks like this. So first thing I see is that, okay, well, it's been flipped over. All right, so it's been flipped downwards. How do we do that? With a negative. Yep, negate the f of x, but I'm gonna do it on the absolute value of x. And so here, step 2, move this over. Oops. Step 2, flip f of x on the x-axis, or upside down. Been a while since we did these, right? But that's going to look like this. Negative absolute value of x. If I put the negative on the x, that's going to do something different, right? That's going to flip it. Doesn't actually do anything to the absolute value function, right? But because any positive would be negative inside, but then the absolute value would turn it positive, right? But if you're flipping this way, which is kind of more common, then you put a negative on the outside of the function. What else has been done? We can check and see, okay, the slope of just the absolute value of x is 1, right? And so what we can do is we can check to see what the slope would be. And you can confirm in either direction. The rise looks like it's 2, and the run in either case looks like it's 4 and 4. That makes sense. Should be even. There's no way we can accommodate different. Maybe there is a way, but I don't know how. Different slopes in the absolute value. I don't think we can. So here, oh, come on. Step 3. Absolute value. Oh. Is that in here? Or? Let's see. I'll just hop in and mute. I keep meaning to change the settings. It's supposed to just mute everyone, be normal. Why that isn't the default, I'm not entirely sure. No one wants to come in and be unmuted. Oh yeah, step 3, adjust the slope. Adjusting the slope looks like rise over run, 2 over 4. I'm gonna go with 1/2. So then, how do I adjust it? I don't want to manipulate the x, I want to manipulate, so the y equals mx plus b, and so the m multiplies the x, or the absolute value of x. And so I get f of x is negative 1/2 times the absolute value of x. There's 2 more moves, and then we'll be done, right? What were the other moves? Well, from the original 0, 0, right, we've moved over to the right by 1, right? So if I want to move on the x-axis, I have to, yeah, exactly, do, for me, the opposite of what I want to do, and say, okay, step 4, move the graph to the right 1 unit, which is going to look like, and I need just one more line. Eek. Just going to look like f of x is negative 1/2 absolute value of x minus 1. What's that backwards one? And then, so we've flipped this, right? We flipped it to look like this, and then we adjusted the slope. So now it looks like this. And then we moved it to the right. What's the last thing we need to do? I need to move it up. So this point needs to move up 2 units, which we can do by using a color. Wow, okay. Step 5, move up 2 units. So f of x is negative 1/2 absolute value of x minus 1 plus 2. We can check this in Desmos. And I can't remember which side is the side where you can see both, not that side. There. If I do -1/2 times the absolute value of x minus 1, and then step out of the absolute value there, plus 2, I can make sure, oh, come on, that I'm crossing these points. Let's do this so it's bigger. What? There, less overlap. But that should look like the graph that we had, right? -3, 0, and 5, 0. Let's just confirm. -3, 0, 5, 0, point at 1, 2. All good. So you can confirm it. Obviously on the test, you can't confirm it, but it's nice for when we're learning to be able to. Let me just crop this up here. And I'll just sneak it in there. Somewhere on the page. There. Nice. Pretty tricky stuff, I think. I wouldn't make you do anything quite so elaborate. But this was five adjustments. I'd go for like maybe 2 or 3. I would expect to, if I gave you a graph, can you make 2 or 3 adjustments? Not all 5. That's a lot. Lower expectations?
I said you low expectations.
Oh.
Just being nice.
No, I'm gonna save all my goodwill for later in the course. Also, I don't really care about graphs so much because we have tools like Desmos and things like that, but old school. Okay. Can we solve absolute value functions? So the absolute value of 2x minus 3 is equal to 8. Okay, let's just have a look at what the graph looks like to see what it is that we're actually solving for. So put this on that side. I need the absolute value of 2x minus 3, absolute value. And what I'm going to do is I'm going to put a line at y equals 8. Just to show where it is. I think you can do it like this, but it shows the solution, and that's not really what I'm going for. And so I'll do another line at y equals 8. Oops, I guess I have to tell it y equals 8. There. So what we want to find, making this a little bit bigger here, is where does this absolute value function equal 8? Okay. Notice that there's 2 solutions, right? And so there's 2 values of x where this is true. Okay. And so that's what I mean by if I did this equals 8, then it just puts lines at the solutions, and that's not really helpful, I think. Oops. So first I'll bring this in. This is where it would be very helpful if you could kind of imagine the graph, right? Not necessarily using Desmos, but if you have 2x minus 3 I kind of ignore the 2x because all I really care about is the general shape, and then -3 has been shifted over by 3, and then that's it, right? Something happened to the x's, but generally the shape is this v that's just been shifted over, and then at 8, right, I can imagine it crossing this line twice. Okay? So how are we going to solve this? Right? So here, if f of x is the absolute value of x, well, then it's going to be x if x is greater than or equal to 0, and negative x if x is less than 0. Really what that means is, okay, instead of x, I have 2x minus 3. Okay? But what I can do is I can solve where 2x minus 3 is equal to 8. But I can also solve where negative 2x minus 3, so it's all negated, is equal to 8. Okay? So we solve where 2x minus 3 is equal to 8, and where negative 2x minus 3 is equal to 8. If you prefer, you can make it -8, but I like putting the negative on the inside stuff. Okay, so solving for x in both cases, and I'm going to do them kind of side by side, one at a time, obviously, but side by side. So then I get 2x is 8 plus 3, usually 11, right? I like to keep my options open. 11 divided by 2, I'm going to go for 5.5. Mostly because that's what I have on this graph, right? And so what we've found is that, okay, on the positive arm of the absolute value, right, it's going to cross at x equals 5.5. How about on the negative arm? For a little bit of practice, so this negative, you can move it over and make it -8, right, by dividing by -1, but I'm going to spread this negative inside. So I get -2x plus 3 is equal to 8. And so I get 8 minus 3. So -2x is 5. So x is 5 divided by -2, or -2.5. Which I'm hoping, phew, is the other guy, right? It helps to have the graph to check against, obviously, but in the end, it doesn't even matter. I can do this. Yeah. So 2 solutions. Therefore, f of x, or I guess we didn't call it f of x. It is, but the absolute value of 2x minus 3 is equal to 8 at x equal to -2.5 and x equals 5.5. Wait. I'll bump this down. So 2 solutions. We're going to do the same thing, but slightly bigger function, right? One thing to keep in mind is that the piecewise function it really only applies to things inside the absolute value. So what you want to do is you want to kind of solve for the absolute value function. So you get just the absolute value on its own, and then you can use the piecewise function. Okay, so here we need to get the absolute value of x minus 1 on its own. But besides that, nothing new. All right, so just kind of peeling away at 4 minus 2 times the absolute value of x minus 1. Where does it equal 1? Oops. We can imagine what this thing looks like. Now I have a negative slope essentially, right, with the -2. So it's been flipped upside down, it's been moved over to the right by 1, and it's been moved up 4. Roughly should look like, I don't know, something like this. Where does it equal 1? Right, we're gonna have 2 solutions again. Right? So just being able to look at that and say, okay, I think I know roughly what that's going to look like, gives you an idea of what the solutions might be. Notice I didn't spend any time working on the slope here. Should be steeper, I guess, but there's no units, so I'm off the hook. All right, so we need to get x minus, or the absolute value of x minus 1 on its own, which means that -2 times the absolute value of x minus 1 is 1 minus 4, -3. The absolute value of x minus 1 is -3 divided by -2. I'm going to go with 1.5. You can use the fractions if you want. Doesn't matter. Now that we have the absolute value on its own, now we can solve this doubly. So x minus 1 is 1.5, and negative x minus 1 is 1.5. X is 2.5, and negative x plus 1 is 1.5. A little bit more work, right? I need to subtract 1, so 0.5, and then move the negative over. So I get x is negative 0.5. Okay. Should we check it? Let's see here. 4 minus 2 times the absolute value of x minus 1 and the absolute value. And at y equals 1. Y equals 1 crosses at -1/2 and 2.5. Nice. I don't have room for that screenshot, so I have to survive. Just little?
Yeah.
I'll move it over. Doo-doo. How about up here? Come on. Weak. Crop top this. There. Sneaky. Okay. Can you even solve this? No. Why? And the absolute value function doesn't yield negative numbers. It only yields positive numbers, right? And so here, we can't solve this. Since the absolute value function only yields positive values. You had to imagine what this graph looks like. So the absolute value of x, and all that's been done to it is it's been moved over to the right by 4 units here, but everything else, it's that familiar b. And what's it asking us to do? It's asking us to figure out, where does this thing equal -2? It doesn't, right? And so there are no solutions. Another thing you could have thought about, or might have thought about, I should say, you could have thought of this. No, you might have thought about is, what if I just move this over to the other side, right? Then I have this scenario, right? And I've just flipped it on its head. But then I don't have this negative anymore, and this is at +2. And so I still don't have any solutions, right? Even in that kind of flipped scenario, because then you've used up the negative, you've moved it over to the left-hand side. So now this is positive, and either way, you're chasing this line that you're never going to cross, right? And that means there's no solutions. Yeah. Wow. This is going to be one of those you had to be there. If you're reading the notes later, wow, what happened here? Good thing I video it. You'll never find it though in the videos. Put 0 effort into those. I just download them and upload them. Surely there's a better way. No editing happens. Okay. So in the same way, we can talk about how many horizontal intercepts are we going to have. We've seen horizontal intercepts. That's where we cross the x-axis, right? And so the horizontal intercepts, let's make a little reminder where we cross the x-axis. In this case, there are no horizontal intercepts because it never crosses the x-axis, right? In kind of the same way that we never cross -2 or 2, depending on how we've manipulated the function, right? Still no solutions. And so we can have 0 horizontal intercepts, and that's okay, right? We're looking here at the x-axis. We could have just 1 horizontal intercept, and that's if the point of the V is just on the x-axis, right? So I haven't moved it up or down anything. Or kind of most commonly is if you have two horizontal intercepts, look like this. I guess I'll do a little pink dot there. The horizontal intercept is where we cross the x-axis, but it's also where y is equal to 0, right? And I guess I should say f of x is equal to 0. Properly. You can use y though. Makes more sense to me. Fine. Or y is equal to 0. Do both. So instead of me giving you values to solve for, right, like this, or where it had to equal 8, for example, I might just ask you to find horizontal intercepts, which is also making sure that you know that, okay, a horizontal intercept is where it crosses the x-axis, which means that y must be 0. So if we have this function, f of x is 5 times x minus 2 minus 3, then might be helpful to know what this thing looks like. 5 is the slope, so it's just kind of made the v tighter. Right? X minus 2 moves me over to the right by 2 units, and then minus 3 plunks me down 3 units. Right? And so maybe something like this. Roughly. And we want to figure out where does it equal 0. This is the same problem as what if I ask you to find or solve 5 times x, the absolute value of x minus 2 minus 3 is equal to 0, which is what we have seen already. Again, we need to get the absolute value function on its own before we can apply the piecewise, right? And so I'm going to start chipping away at this thing. I'm going to move 3 over to the right-hand side and then divide by 5. Working my way in. So 5 times the absolute value of x minus 2 is equal to 3. Which means the absolute value of x minus 2 is 3 over 5. Can be the positive version or the negative version. We're going to solve both, obviously. So x minus 2 is equal to 3 over 5. Now 3 over 5, does that make anything nice or not really? Asking for a friend. I'll use my calculator. Wait. Gotta respect my calculator. 0.6. Oh, that's nice. Plus 2. X makes 2.6. And negative x minus 2 is 3 over 5, or 0.6. So negative 6 plus, or negative x plus 2, rather, is 0.6. So 0.6 minus 2 is negative 1.4. So x is going to be positive 1.4. Even though I made a very rough sketch here, right, it does check out with what I would expect it to look like, right, to positive values. You want to be careful because sometimes if you're not doing the slope properly, right, you could be over on the negative side, but in this case, it looks reasonable, and we'll use Desmos to confirm.
You forgot your negative on the 1.4. Oh, wait.
Oh, I did it in, because I don't have any more room. So then I did minus 2, and then I have negative x is 0.6 minus 2, so negative 1.4, and then I ditch the negatives. Technically, you divide over by the negative, but a negative divided by a negative makes a positive. I'll do it here. Negative x is negative 1.4. But a negative and a negative, really, we can just cancel this. Okay, let's see what this looks like. Okay. 5 times the absolute value of x minus 2 absolute value minus 3. And we wanted to know where it crosses the x-axis. Oops. Eek. Now where am I going to put this? There. Nice. Any questions so far? No? We've already seen this, but what's new here? Now I have an inequality. Wow. That's okay. We can treat the inequality as an equal sign until we multiply or divide by a negative number, then it switches the direction of the sign, right? And so here I'll make a note. Got this pounding in my ear. It's not great. It's just the one ear though. It's weird. We can treat the inequality, which includes less than, greater than, less than or equal to, greater than or equal to. Technically even not equal to, but it behaves like an equal sign. So the inequality as an equal sign unless we multiply or divide by a negative number, bless you, then we have to flip the direction of the sign. We multiply or divide by a negative number. Oops. Then we need to change the direction of the inequality. So if we have to solve this thing, 3 times the absolute value of x minus 1 and then plus 1, where is it greater than 7? There are 2 ways that we can do that, or kind of 2 common ways. And I do a mashup of the 2. First, let's graph it. That's going to be hard to do maybe in a test scenario. And so I want to give you a non-graphing option. Okay, but first let's graph it so we can see what's going on. So I've got 3 times the absolute value of x minus 1. Hey, where's my x? X minus 1. And then plus 1. where's this thing greater than 7? Oops, I'll do y equals 7 on here, which is very similar to how we're going to solve this thing. So it's going to be greater than 7 for all those outputs above this line. All right. Let's see if I can, because I want a nice non-overlapping graph. I'll throw the vertex on there just in case. Can't hurt. Move to the right one, up one. So many screenshots today. My camera roll is not very exciting. So where is it greater than 7? Not including 7. And that's something we'll check in on at the end. But where is it greater than 7? It's greater than 7 on this interval, or there's 2 intervals rather. So as soon as x is greater than 3, start on the positive side, right? Then the output is greater than 7. Right? And on the negative side, right, if the x is less than -1, just because of how negatives work, right, then the output is greater than 7. So how do we solve this thing without a graph, maybe? Let's see here. I like to just turn my inequality into an equal sign, and that's kind of bad. But what am I really doing? I'm really treating it as if it's the line so I can find these cutoff points, right? And so we can find, I'll call them the transition points. These transition points by setting f of x equal to 7. That's easier to deal with. Then I don't even need to worry about flipping the inequality if I deal with a negative, right? Multiply or divide by negative. So that's nice. So 3, oh, I guess I've got it there. 3 times the absolute value of x minus 1 plus 1 is equal to 7. I still need to get that absolute value function on its own. And so I'm going to chip away at it by subtracting 1 from both sides and then dividing by 3. So I get 3 times the absolute value of x minus 1 is 7 minus 1, which is 6. And so the absolute value of x minus 1 is 6 divided by 3. I'm just going to go for 2. I can tell I'm going to need another page, so I'm just going to add it now. I know what you're thinking. Yeah, well, we were almost done here. I know, but the inequality though. So we can solve x minus 1 is equal to 2 and negative x minus 1 is equal to 2. X is 2 plus 1, which is 3. Hey, that sounds familiar. All right. We just saw it on our graph here. So that's this little guy. And then we have negative x plus 1 is 2. 2 minus 1 is 1. and then negate that, so x is -1. Okay. So halfway there, sort of. How are we going to find where this inequality, so where is it greater than 7? So we know that those two are the transition points. Now, it's very obvious when you have a graph, right? But let's pretend you don't have a graph. Okay. Assume we don't have a graph. And maybe we don't want to rely on our graph visualization skills. And don't want to rely on our graph visualization skills. That's fair. I used to hate, but I still don't love graphs and kind of manipulating graphs because it's hard and I don't like doing hard things. But I'm getting better at it. Also been teaching it for like 10 years, so there's that. Eventually, you're gonna learn it, I guess. But what if we don't have that? So then what I want you to do is we can use what's called a sign chart, or let me see what he uses it. Yeah, okay, so using sign charts, good. We can use a sign chart to find the solution. We know there's two. Right. Okay, so what we're gonna do is we're gonna draw just a number line, which is going to represent this line, okay, at 7. But for us, it's just going to be a number line. And what we're going to do is we're going to include both our solutions on there. We know something happens at that point, right? Whether it's facing up or facing down, right? That's going to determine where the solutions are. Okay? And without too much visualization, we don't really know which direction. But this is where it goes like this. So step 1, add the solutions to a number line. I had x is -1 and x is 3. I just space them out nicely. Well, not really paying attention to. We're going to be doing work in each of the sections. And so that's why I just kind of space them evenly. What's that work, you ask? Well, you can have your function, your original function, 3 times x minus 1 plus 1. And what you can do is you can plug in test values of x, right, in each region. And if it's greater than 7, then it satisfies that criteria. And if it's less than 7, it doesn't, right? So maybe let me just remember what this is, copy it down. Okay. I'll put it up here. And we want it to be greater than 7. Okay. Step 2, pick test points in each of these regions. in each region. I like to pick kind of easy values to work with, right? Definitely a go-to for me is 0. If I have a negative and a positive, I'll plug in x equals 0, see what happens. How about on this side, as long as it's less than -1, let's go with -2, right? Or if you can see kind of an easy value of x to work with here, then go for it. But I'll just do -2. And we also need a test point on the other side of 3. So let's go for 4. Why not? These are arbitrary. You can pick any points in those regions. Okay. What's my next color? Step 3, evaluate 3 times the absolute value of x minus 1 plus 1 in each region at each test point. Or I guess I just need to say at each test point. So this is where we're going to do math 3 times over, same math, right? So now I'm just going to copy this down here. We're going to have kind of breaks here, breaking up my work. 3 times absolute value of -2 minus 1 plus 1. Bless you. Is -2 minus 1 is -3. And maybe I'll do this. It's tough because we don't have very much space. 3 times the absolute value of -3 plus 1. Absolute value of -3 is 3. So 3 times 3 is 9 plus 1 is 10. This is greater than 7. What color haven't I used yet? Greater than 7. I'll make another step later, but let's just do this work so we can see all the regions. From the graph, now we are saying we don't have a graph, right? And we don't want to risk it and try to pretend that we can draw this graph properly on a test. So this is the safe way to do it. But from the graph, we know that this region is not where x is greater than 7, right? We had this V, and that's where the bottom point is. So in this region, I'm expecting this inequality to be less than 7, right? So let's try it. 3 times, and I picked 0. 0 minus 1 plus 1, which is the absolute value of -1 is 1. 3 times 1 is 3 plus 1, or 3 times the absolute value of -1 plus 1 is 4. Not greater than 7. Right. Less than 7. It doesn't satisfy that initial criteria that we had. And maybe I'll do this. I'll highlight where my points are coming from. And as long as you're in this, in each of the regions for your test points, like I said, you can pick any values that you want, right? You're just testing because it'll behave the same past these cutoff points. And then finally, 3 times the absolute value of 4 minus 1 plus 1 is 3 times the absolute value of 3 plus 1 again, which is 10, which is greater than 7. Oh, and I'll highlight this 4 came from there. Cool. So now we know that, okay, in this first region, yep, it's greater than 7. And then it makes sense because of, we know the absolute value function, what it looks like, right? So then for a little stretch of time here, it's not greater than 7. That's okay. And then after 3, it's greater than 7 again, right? And our solution is on an interval, right? In fact, it's 2 intervals joined up. Okay. And so the solution is an interval, oops, which is going to be what? Maybe I'll do this, copy that again. Now, what I like to do is I like to do a little check mark where it works and a little X where it doesn't. Just to remind myself. But really the cutoff points that we're interested in are these -1 and 3, right? That's where it transitions over into being positive again, or over 7 rather. And we wanted it to not include 7, right? Because at those points it is 7. But we do open points, right? And this interval and this interval. Oof, intervals, that's been a while. Okay. -infinity. So the solution is -infinity up to -1, but not including -1. All right. Union from 3 up to +infinity, but not including 3. This is the solution. I told you I'd need another page. There it is. Yeah. We're going to use this concept of picking test points and using a number line again and again. And so this is the first time that this is the first time I'm seeing this. Right, but we're going to use it again and rely on this. And so it's worth kind of getting to know it and kind of working with it a little bit. Okay? And it means you don't have to visualize the graphs, which is nice. You can confirm with a graph, right? Talk yourself into it, right? But it's just doing this, right? Where this is a solution up to not including -1, then not a solution, not a solution, then starting at 3 but not including 3 is a solution again. Whoa. Inequalities with absolute value functions. For what x values is f of x greater than 0, given f of x is the absolute value of x minus 3, then -5. This is the same thing that we were doing, right? And let's do it without even pretending to know what the graph looks like. Although we know, what's it gonna look like? We can't help it. We take our V, we move it over to the right 3 units and then down 5 units. And then we wanna know where it's greater than 0. I know there's going to be 2 regions where that's true, but let's assume that we don't have any graph knowledge. How do we solve this thing? Okay, so we need negative x minus 3, or the absolute value of negative x minus 3 minus 5 to be greater than 0. First thing I'm going to do is solve those transition points. Absolute value of x minus 3 minus 5 is equal to 0 to find the transition points. Again, I need to get the absolute value function on its own, so I'm going to move the 5 over to the right, and so I get the absolute value of x minus 3 is equal to 5. Okay. Fair enough. So then x minus 3 is equal to 5, and negative x minus 3 is equal to 5. X is 5 plus 3, which is 8, and negative x plus 3 is equal to 5. So 5 minus 3, negative x is not negative 2, is 2. So x is 2. Okay. Yes, thank you. Usually I punish myself by doing it in red, but you caught it soon enough. I feel like I'm off the hook. Thank you. Okay. So now remember, no graphs. Next step is the number line, right? So we're going to pick test points and set this up. I use my whole page and I'm going to put -2 and 8 on here. It's a number line, so they have to be in order. And then I'm going to just pick values again, kind of picking easy values. Are there any values I want to work with? Not really. -3, I always want to work with 0. Personal preference. And then maybe let's do 10. I don't know. Something nice. Okay. So then I'm going to work with the original function just because the original function is the one that has the inequality, right? And so we want to solve where this thing is greater than 0. Copy. Find the absolute value of x minus 3 minus 5. Where is it greater than 0? And so I'm going to do the absolute value of -3 minus 3 minus 5. -3 minus 3 is -6. Okay, I'm gonna have to do something weird here. The absolute value of -6 minus 5 is 6 minus 5, which is 1. That's greater than 0. How about the next region? 0 minus 3, absolute value, minus 5 is the absolute value of negative 3 minus 5, which is 3 minus 5, which is negative 2, which is less than 0. Not what we want. And then finally, the absolute value of 10 minus 3 minus 5 is the absolute value of 7 minus 5, which is 2, which again is greater than 0. It's equal to 0 at these transition points, because that's what we forced when we solved for these points, right? We forced it to be equal to 0. But we want to exclude equal to 0 here and just be greater than 0. And so again, we exclude those transition points, negative 2 and 8, from our interval. And so therefore, the solution is the interval from negative infinity to 1, not including 1, joined up with picking up at 2, but not including 2, and going to infinity. Yeah. Can graph this. But that's how you would solve it, right? And then let's check our work with our graph. Okay. Where is it? Absolute value of x minus 3 and the absolute value minus 5. And we wanted to know, where is this thing greater than 0? We found those transition points, and then here it's easy to see that, okay, from negative infinity up to x equals, or x equals negative 2, but not including negative 2 and 8. I think so too. Like negative 2. Is that what happened here? Before I commemorate. Oh, I did too. Oh boy. Emily. Well, this warrants red, doesn't it? Negative 2 and 8. Bad. Bad. Sloppy, sloppy. I just went for these little guys. That's wrong. There. At least class wasn't over yet. Okay, but then I did take a screenshot, right? Let's see, can I bring it in? Can I do it? Yes, I can. So here, bink, bink. Once I adjusted my interval. There. Okay. Any questions about that one besides my mess up? Okay. Oh yeah, this.
Oh, we started with 8. Okay.
Yeah, the 8 is where is one of the points where it's equal to 0 and negative 2. Okay, pretty sure. I know, kind of disappointing. That's the end of the chapter. Womp womp. Yes. I'll do the end of chapter 2. Question 2. Yes, I can. Let's see here. Ba, 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 ba. Homework from section. Which section? 2.3. And we'll have different numbers, but I'll do it with whatever numbers I get. No, because I'll grab the, let's see here.
Well, I meant like, not the one up, the one.
Oh, like the one I posted. Oh, yeah, sure. Then, this one,
Yes. What?
let me copy pasta.
Social wisdom. This is section.
Did I post the solutions yet? I don't think so. I'm having this memory of,
Yeah. Like, I know it, so.
okay. So this one, there's a couple of different ways that we could solve this one. I would probably just use the years as they are, but a typical move that we would do is we would set whatever the first year is to be 0, and then we would talk about years since 1970, right? It makes the interpretation a little bit weirder, right? So years, so X is now in years from 1970, but then you can force this to be 0. But let's solve it just treating the years as your X and the output as the population size. So let's do this. The years just kind of keep ticking along. And so for that reason, I'm going to put those on the x-axis. And we're told here at 1970, we've got a data point, and at 2000, we've got a data point. We're told in 1970, we're at 1.2 million, which would look something like this. Bless you. 1970 and 1 2 0 0 1 2 3 zeros. And again, you could change the units to be in thousands maybe, or something like that. But I'm just going to use the raw numbers and show you that you can do it. It's just kind of annoying. But then making kind of unconverting the numbers from thousands and years from 1970s also work. So I don't know. 595,000. So here, right, a decrease, and the year is 2000, and we're at 595,000. That's
Would it be like at 1.2 million minus 5 million?
so the number dropped to yeah, so not by 595, but to 595. So now if this trend is linear, which it is not necessarily, but if it was, and continues, when will the bluefin tuna be fished to extinction? What does that look like? Let's just kind of sketch a line here. It's linear. Should I use my ruler? Then I'll use red. This is where we're at 0, right? Then the population size is 0. So where is it? Where does this line cross the x-axis? And so this is the population size. If you ignore all the words, right, or rather not ignore them, but once you've converted all the words into these 2 points and figured out what you're trying to solve for, then it's the exact same type of problem that we've been solving already, right? We have 2 points and we need to find where it crosses the x-axis. Okay. So what do we? Pardon?
Oh, you wrote population on the left of your graph?
Yeah.
That was that size.
Yeah,
Oh, okay.
I know. 7, yeah, no. Size. Still not great. Okay. When we're constructing a line, first we find the slope. Right? The slope is f of x2 minus f of x1 over x2 minus x1. Which in this case, f of x2 is 595,000 minus f of x1 is 1.2 million, so 0, 0, 0, 0, 0. X2 is 2000 minus x1, which was 1970. I'm gonna do that here. 1, 2, 3, make sure you got all your zeros. I get negative 605,000 divided by 30. Which doesn't make anything nice. Oh, maybe it does. Negative 20,166.66667. I feel like it has room for more digits, so maybe that's where it ends. I don't know, close enough. 1, 2. Maybe not. Oops. We'll use that. Slope is negative. Makes sense. I'm expecting it to be a negative relationship. Then we know, so next we need to find the y-intercept. All right. We can use one of these 2 points that we have, and it doesn't matter which one we use, right? Y equals mx plus b, where y is negative 2,0,166.6667 x plus b at either 1970, 1.2 million, 1, 2, 3, or 2,000 and 595,000. As long as you put in one of those points, one of those XY coordinates, right? In this case, XY, XY, just one of those. Let's do the first one. Doesn't matter. So y is, I'll just rewrite it because I'm on a new page, which is more for later than for now. Y is 1.2 million, 23, negative 2,000 or 20,166,666,667 times 1970 plus B. I'm trying to solve for B. I'm gonna use this value that's already on my screen in my calculator, right? And you can store values if you want to make sure that you're not rounding stuff. But I'm going to multiply it by 1970. And I get 1.2 million, 1, 2, 3 is negative 3972833.33 plus B. Solve for B, I need to add that over to the other side. And so 1.2 million, 1, 2, 3, minus that negative answer. I get B is 4092833.33. Which means that y is negative 20,166.6667. And you're welcome to use the fraction if you want, but I obviously haven't been. 4092833.33. We want to find the year, so X, where Y is 0. Let Y be 0. Y is the population size. We want to know when will it be fished to extinction. And so we let Y be 0. So 0 is negative 2,0166.66667. Way less tedious if you don't have to read it all out. Plus 4092833.33. I'll pull a fast one. I guess in theory, you could add this chunk over to the left-hand side and then divide the positive version of the slope over to the left-hand side, which is what I'm gonna do. But I guess in my mind, what I do is I subtract, this is weird. In my mind, I subtract this to the left-hand side, and then I divide by this negative, and then I drop the negatives, and then I switch my equal signs. That's weird, but that's how my brain works. Yes, either way, we end up here. 4092833.33 divided by 20,166.6667. I get roughly 2029.504132. So sometime between 2029 and 2030. I know, how ominous. That's assuming a linear relationship. Curious to know if that's true or not. Hopefully not. That feels like it's a little too late if it is. Kind of headed down a nasty path there. No more bluefin tuna. Oh, I know. I have a Oh, it'll be a total surprise. I don't think there's a tuna, but tuna sticker. They look so happy. They don't know, they don't know what the question's about here. Little tear. All of these are sad. All right, any other questions? No? Yeah, so I realized yeah. I haven't posted those solutions, but I will because I have made them, so I'm not sure why. I think it was an internet issue. But if you have any questions, let me know. Otherwise, I'll see you on Thursday.